Okay, today's lesson is on the converse of the Pythagorean theorem, and that means that we are going to go backwards. Remember that the converse is when we switch the if part of a statement with the then part of the statement. So what we will be attempting to accomplish today is to prove that if we know a squared plus b squared equals c squared, then it is a right triangle. And really the way that you prove that is by using the side-side-side theorem. If you draw a triangle with three sides that are equal to another triangle with three sides, then the two triangles are congruent by side-side-side. So if the first triangle has a right angle in it, the second triangle has to have a right angle in it. And that's kind of the foundation of the whole thing, and I'm not going to go into it in great detail since I'm not there today. I am going to tell you that if the hypotenuse side, the c squared, comes out greater than a squared plus b squared, picture it. The hypotenuse side is longer. What is that going to do to the angle that is across from the longer side? So here's kind of a picture. As I change this angle, this would be a right triangle if we connect it. If I make the angle bigger, isn't the side across from it becoming bigger? And that becomes an obtuse triangle. As I make that side across from the angle shorter, the angle becomes smaller and it becomes an acute triangle. So, if c squared is greater than a squared plus b squared, we have an obtuse triangle. Whereas if c squared is less than a squared plus b squared, that makes the angle smaller, which means we have to have an acute triangle. Okay? So here's what this looks like. If we square the longest side so that it's greater than the sum of the other two sides, we're going to have obtuse triangles. If we square the longest side and it's less than the squares of the other two sides, we are going to have an acute triangle. Okay? So, if we have a triangle with sides 5, 12, and 15 centimeters, we will take the longest side, 15, and square it. We don't know if it's going to be equal, greater, or less. We will compare that to 5 squared plus 12 squared. 15 squared happens to be 225. 5 squared is 25. 12 squared is 144. That means we are comparing 225 to the other side, which comes out 169. 25 plus 144 is 169. That makes the hypotenuse side bigger, which means we are going to have an obtuse triangle, not a right triangle. This next example is a picture of like when Amish people build, or if you've ever watched the home makeover program, we build a wall that's laying on the ground. It's easier to assemble this stud wall on the ground, and then a whole bunch of people get together and they lift it up and they stand and put the wall in place together. So what we would like to check and see is, does this picture of this wall, did they make right-angled corners or not? Basically, are they good at construction or not? We would take the hypotenuse side that is 17 squared, compare that to 8 squared plus 15 squared. 17 squared is 289, 8 squared is 64, 15 squared is 225, and if you add those together, you will find that we have 289 on both sides. So yes, indeed, we have a right triangle. They have made right corners. Okay. So let's move on to, what if we have a triangle that has sides with lengths 6, 8, and 9? What kind of a triangle is it? The answer to why is going to be in my algebra work. I am going to take the longest side, 9 squared, and compare that to 6 squared plus 8 squared. That means I am comparing 81 to 36 plus 64, which means I am comparing 81 If I add 36 and 64, I get 100. And 81 is less than 100, so since this hypotenuse side came out less, I have an acute triangle. In the next example, I have 6, 8, and 10, so I will take the longest side, 10, and I will square that and compare it to 6 squared plus 8 squared, which means 10 squared is 100. I'm comparing that to 36 plus 64, and that means I end up comparing 100 to 100, which comes out to be equal. If they come out equal, then I definitely have a right triangle because the Pythagorean theorem actually worked. The last question up here is there to remind you. It says, what type of a triangle has sides of 3, 4, and 9? Please remember that you have to add together the smaller two sides, and it has to be greater than the third one in order to even be a triangle. So 3 plus 4 is not even greater than 9, so this is not a triangle at all. In every other example, 6 plus 8 was 14, so that was bigger than 10. And again here, 6 plus 8 is 14, so that is bigger than 9. Those did determine triangles. But you do have to decide if you even have a triangle before you get started on working these problems. Okay? So today's concept, you are plugging into the Pythagorean theorem. If it works, you have a right triangle. If it does not work and that longest side comes out bigger, you have an obtuse triangle. And if that longest side comes out smaller, you have an acute triangle. Good luck!